So here we have a student class that we would like to be able to perhaps map to a relational representation, right, in a relational database. And here we have some fields that are clearly part of the student, right, like the name of the student, the graduation year, whether they change to the graduation year, whether they change to a different department. But notice that some of these, like the major, right, or the enrollment, right, those are related to something else, something that is not part of the student, that is represented elsewhere, right? And so we would like to be able to see, well, how would this be represented in a relational database, and what are the implications, right, that we want to map these things. If I load the students, would I also load the enrollments, right? Or would I load them maybe perhaps when I actually need them, right? If this were only represented in memory, in RAM, right, there would be no question. I would always have everything stored in RAM, right? But if these are somehow bagged by some backend, by some database, probably I would not want to load them until they are necessary, right? It would be kind of like a lazy loading. Only when I actually need it will I go fetch it in the database, and I would populate these records on demand, right? So there's several aspects that we would like to consider. Same thing with major, right? If I fetch the department, well, what about the department? Does that object department, does it just have maybe the name of the department, maybe who the chair is, and when it was when the department was created, perhaps what the address of the department is, right? But what about if the department has a list of courses, right? That would I also load the list of courses for that department, right? And if those courses have a list of students that are enrolled in those courses, would I also load the students that are enrolled in those courses that are in that department? You see the problem, right? You know, where would I draw the line and say what am I actually going to load in memory, right? And which things are going to perhaps lazy load as I need them on demand, right? And so that mapping is also very very important, right? So we would like to be able to somehow understand, right, that certainly in the relational database we're using one way to capture the relationships, yes, using foreign keys and primary keys. Notice that those are fields that are not natural fields, right? They're not actually part of the data model. They're only there, right, to sustain the support for the relationships between the various records, right? They're artificial. They're artificial fields, right? So what we would like to be able to identify is that some of these, right, are capturing some one-to-many or many-to-many relationship with other instances, right? Such as, you know, getting the students presumably in a relational database. Typically, those students will have foreign keys back to the department. Or here, the courses, typically you'll have course records that have foreign keys back to the department, right? Same thing here. We have enrollment. If we want to get a hold of the students, or we're going to get a hold of the sections, typically this will be implemented in a relational database by this map being kind of like a mapping table, right? Where you have foreign keys pointing to, hey, that student over there is enrolled in that course over there, right? Or in that section, sorry. Okay? You would actually have the list of students or the actual section instance here, right? But the way we would like to implement it in an object representation is the actual object, right? I don't want the ID. The primary key is really, or the foreign key is useless to me. You know, actually populate it or give me the actual instance object that would go along with this. Okay. Same thing with section and courses. These are all these enrollments for a particular section. It will be represented by foreign keys in the enrollments pointing back to the section. Okay. Same thing for the course. I would like the actual department as opposed to a foreign key to the department. Right. And this should be transparent to me, right? That as I navigate throughout the object model, right, the back end or whatever technology we're using, would go and fetch all this from the database and fill it in as we are consuming the data. So for instance, I would like to be able to retrieve the students, and as I go through the students, get the enrollments. Right? Again, would I actually have the enrollments? Probably not. Not until I demand them, right? Not until I really need them, would it go and actually fetch this from the database and retrieve for them and get the section. It would load the section for me, load the object for the course, and then load the object for the section. Right? It would be very, very powerful. Okay? So we would like to have kind of like a centralized manager, right, that would deal with this, right, that would instantiate all the data access objects, that would make sure that all these instances are loaded. We would be able to configure it whether we want to load them eagerly, right? If we load the enrollment, we also want to load the section, and we also want to load the course, or if we want to do it lazy, right? We want to do lazy loading or eager loading, right? Just meaning that when I instantiate this object, I also want all the objects that are related to it right when I instantiate the parent, or lazy, right? So that as I consume them, go and fetch them as I need them. Okay, that manages all the connections for me. That handles all the primary keys and foreign keys for me, and finds and instantiates all the other instances. It would hold a live connection, right, to the database. It would handle the life cycle of that connection, perhaps even a pool of connections, not just one connection, perhaps, but many connections. This could be maybe multi-threaded, so that as each thread comes in, right, it would perhaps give off a connection to each thread, right, so they can independently talk to the database independently. Here you would just have one connection, but it could certainly be a pool of connections. It would also keep track of all the DAOs, data access objects, that would handle each one of these of the tables, right, and would instantiate the connections, right, and then share them with the various data access objects that would be responsible for each individual table. Each one of them would implement several CROD operations. Certainly, all the finder methods that would allow you to find, given an ID, find a student, an individual student, individual department, and also provide some transactional support, right, that will allow you to perhaps buffer out several data manipulations, right? And once they're all buffered out, maybe commit them and execute them all at once, right? Atomically. So it would provide transaction management as well. Would implement all the CRUD operations, the finders, all the read operations, all the create operations, such as instantiating, inserting students, departments, sections, courses, and whatnot. So here's a couple that will allow you to deal with them, right? Committing, closing. So here's an example of what it would look like. Instantiate my data manager. Given a particular ID, retrieve the students, and given the student, give me get the major department. So it gives me the department of the student, and then I would be able to insert new students into a database. So this is what the student object might look something like this, right? You would have all the various primitive attributes of the students, such as the name. You have the collection of the enrollments, and they will only be there to be able to be populated by the manager, right? As it loads these instances, it would instantiate the collection of enrollments for that student. So here it probably would implement some very simple. Could implement some simple cache implementation, such as that, if you have data that it's going to change very slowly, right? It probably is safe to keep a copy of that around in memory, right, in RAM, especially since typically, during the session that you're using the application, it's very unlikely that certain things will change very much, right? If you know that within the day the enrollments are not going to change, right, from the morning to the afternoon. Maybe it's safe to cache things in memory. But every time you're caching something in memory, you're always running into the risk that you're working with stale data, right? That you're working with data that was loaded, instantiated, but it could have changed underneath you without you knowing. But again, that's a design decision, right? On how much risk are you willing to take. But again, this somewhat safe, that the enrollment would not change from one day to the next or during the day while you're using it. So this would load it. If it's already loaded, I would just return it. Also, you would implement, again, for the CRUD operations, right, or the updates that would allow you to change the graduation year, change the major. Now, notice that this is changing. Not only is changing the local value, right, local value for the current instance, but it's also it's also notifying the underneath DAO, right, that hey, this has changed, right, this value in RAM has changed, right, so perhaps it should also change in the database, right, so it keeps synchronized, right, whatever you have in memory and whatever is being stored in the database. Again, it depends, right? If it's something that you consider that is very important to keep synchronized between the instance of the what's loaded in memory and what's stored in the database, you do it immediately. Or you could cache them, right? And so all the changes would be cached in memory, and then once you commit, right, all the changes will be written all at once in the database. Again, it depends how you feel about having either the RAM stale or the database stale, right? That you need to synchronize. So here's the student DAO, also keeping track of the connections in the database manager, and also keeping track of what statements it's using to retrieve all of them and how to instantiate them. So this is code we've seen already, right? Querying and retrieving things from a result set. If it's not null, it reads everything from the result set. And here, notice that we have an eager retrieval of the department. Well, we could have chosen that this is lazy, right? That only when we fetch the get department, right, it would then go fetch it from the database. Over here, we chose it to be eager, right? Meaning that when we load the student, we also load the department object from the database, right? And then we instantiate the object. Insertion. So again, you would have all the SQL statements, prepared statements to instantiate these things. So this is pretty much what we would expect, right? Using just plain old JDBC, right? Also getting the enrollments. This is iterating over the enrollments table and getting a hold of. In this case, we are apparently we are not loading the section. Are we? I don't believe we're still loading the section. So we're just loading the ID of the. But the section and the student we're loading them on demand. Graduation year, if we change it locally, we also go out and change it in the database. If we change the major, we also go and update the major, right? And so all these things would be implemented, manually for us, right? By us. Typically, what we like to do is find a tool that does this for us, right? But notice that this tool would have to be very smart, right? That it would have to detect any changes, any state changes with any objects that are unmanaged objects. These objects of students and departments and enrollments are not going to be just plain old Java objects, right? Plain old Java objects just have setters and getters, right, and constructors, right, and have no notions that they're being stored in a database, okay? Whereas these objects are a little more than just plain old Java objects, right? Their setters and getters are actually aware, right, that they are being synchronized with the database, right? So we would like to have a tool that, giving a plain old Java object, right, somehow, right, it would wrap something around that object. It would be aware that any state changes with the data with that object, right? If we call any of the setters, right, it would be aware that, oh, the state of the object has changed. I better go in and synchronize this with the database. Okay, and that's exactly the tool that we're going to be looking today, right? That allows us to treat objects as if they were simple data objects, right? Plain old Java objects, but these objects are wrapped, are converted into what are referred to as managed objects, just like these objects that we're writing ourselves, right, from scratch. These are managed objects that are not just plain old Java objects, but they are aware that they're being synchronized with the data, with the database. All right. So to do that, we're going to use a tool, a library called JPA. All right, so let's talk about JPA.